Hey, it's Jason from the Dental Equipment Repair channel. Today I wanted to bring you along for a compressor repair. I actually ended up finding this repair towards the end of the day here in a dental office that's in my local area. This compressor is a Airstar 50, and this is a older style that uses the uses desiccant, and this is a pretty common unit. It's got two motors, each with two heads, and this is a very common unit. This unit in particular, if you ever want to date an Airstar compressor, as in know how old it is, you can just go ahead and look for a year, and this is 2004. So this compressor is, what is that, 17 years old? So it's over 15, which is about the recommended lifespan for these compressors, or just if you're in a practice running a compressor and it's over 15, it's probably time to start budgeting for a new one. But today we're just going to fix this one. I'll go ahead and show you what the problem is. Now, it'll be a little noisy, but just so you can expect what to see, I'm going to turn the unit on. The heads are both running. The pressure gauge is going to build up to about 100 pounds of pressure, at which point the motors are going to turn off, and then the purge cycle is going to start, which the airflow on the compressor goes basically from the heads here through these two braided lines to this manifold. It goes down through the manifold and then here to a purge solenoid, which is normally open, but it'll be energized shut. It then comes up here through a desiccant tank, and it goes through desiccant. Its job is to remove moisture. From that point, it'll come out the top of the desiccant tank here into this little T. This side over here goes to a purge tank that stores the purge air, and then also through this check valve. Now, the check valve only allows air to go one direction, okay, over here, and basically into the tank itself where it's stored. Then there's actually a black line there and a black line there, which are part of the pressure sensing circuit for your pressure switch, and then some other functions in there. I won't get too much into that, but basically that's all the air piping. Now, what's happening is, before it gets noisy, is basically that air is being pumped through here, past here, and up through here, and then into here, and it's going where it should be going, through the check valve, except the check valve is not closing. So at the end of the cycle, we're going to watch that gauge race down. Now, mechanically, this point as well as this point are the same, because this is just a big tank. So those are actually even pressure. And what's happening is that air is basically backflowing through this check valve because this has stopped working. So now, to fix it, I've actually got a check valve here with me, as well as some various tools. Now, my intent is to show you the repair of this. I'm going to demonstrate it in a failed state, and after the repair, I'm going to show you how it runs afterwards, and we're going to see a couple really clear differences. So we'll turn it on. So now air is bleeding out there like it normally would be, except the problem is, as that bleeds, that gauge, just watch that thing, all right? It should be holding off at around 95 PSI, and it really just never stops bleeding off. And right in around 80, we're gonna hear it kick right back on, and we'll let it run another cycle. the same thing. And basically, this check valve is allowing air to bypass through to here, or actually from here, up through here, this way, which is the wrong way. If you can see, there's an arrow right there, okay? The arrow is actually pointing to the right. So the air is actually bypassing this way, up through here, down through here, over through here, and then it's going through there. And then as you can see, interesting. Well, that was really weird, because you watched it fail once. That's super interesting. So you saw what that did with me. I'm a little befuddled there. Now, I witnessed this malfunction probably 4 or 5 cycles. So let's go ahead and see if we can get it to fail again. I'm going to make a little bit of I'll valve off the office. I'm going to make a little bit of a loud noise here, and we'll bleed it down, let it start, see if it gets caught in that cycle again. Wow, that's super crazy. Okay, I didn't do anything, and that check valve actually worked once, and it's back to failing. This is real time. I literally didn't do anything. Wow. Man, that is super weird. One more time. Wow. Okay, well, I just can't believe what I'm seeing. This intermittent, it's either bad or it's good. So, because I've got the part, I'm going to go ahead and replace this old check valve. And here we go. The strategy I'm going to use to replace the check valve is I'm going to use some, first thing I'm going to do is bleed the system down to 0 for safety. I'm going to turn off the motors because I'm accessing this part of the system which is under pressure. I'm going to take this down to 0. go. It's down to 0. Now, what I'm going to do is we're going to take some wrenches and we're going to undo these pipes right here. And I'll try to get try and get this as good as I can. Let's see. Let's get the right wrenches here. No? Oh my goodness. What are those? So 9/16. Alright, so we'll... Okay, so that guy's off. Now we'll go ahead and... Alright, so we'll take that little guy off. Actually, no, we might not. No, we don't. We need to do that. Okay, the objective here is to free as much of this this tee up as possible. All right. So we're gonna take this guy off. Okay, so there's that guy off. Now we'll go ahead and use our 6-in-1 here. Oh. Well, that was no good. You see that? Pretty amazing. It just broke off. So unscrew. Alright. So that guy is coming off of there. Now we'll take off this side. Alright. Basically what I'm doing is I'm just disconnecting using 9/16 and 7/16 all the external connections here. And in the end, we're going to try to just keep everything nice and aligned. Alright, so and I'm probably going to need to take that guy off too, just to create a little bit of space to get that guy off. Alright, so there we go. Now, this is the check valve right here. You can see there's an arrow. So the new check valve that we put on, we'll go ahead and put it in that same direction. It looks a little different, but it fulfills the same mission. Alright, so we'll go just like that. So check valve, like that. Alright, so let's see how I can bare-hand it here. We need to disconnect basically that thread and that thread. So have the two smaller ports pointing the same way and be fairly level. So let's see what we can do here with my bare hands. Nope. Alright, so for this job, we'll go ahead and get a crescent on there, big crescent. And we'll use another big crescent here. And we'll kind of just see. It's kind of hard to hold. But... Alright. kind of ugly, but it's how it is when you're working by yourself. Okay, so now, well, that's not what I want. All right, so. What I want is, I want for it to disconnect about right there. So let's try here, see if we can get this inboard joint done. And this is not the easiest of endeavors here, but it'll be okay. All right, so we broke that guy free. Now I have to figure out how to break that guy free. Now this might just be a little ugly. I'm gonna try not to damage the pipe, which means I might just grab right here and try and use that rubber in order to turn it against there. I don't know if that's gonna work or not. Probably won't. So now what I've got to do is go ahead and crimp onto that pipe. Now, we'll see. Hopefully we can get it to turn without damaging it. Too bad. There we go. Okay. There we go. Just some light tool marks. There we go. Okay. So, wasn't so bad. We're going to use some pipe thread tape, which is, I think I saw it go blowing off somewhere. Here we go. So now when you're using pipe thread tape, you want to go ahead and act like you're turning. Alright, actually if you're tightening it, okay? And then we'll do it the same on this side. Yep, that little guy just was kind of sticking. Don't know why. But we witnessed it. It was kind of crazy. It was a little bit too much of a failure for me. Okay, so now we put the pipe tape on there. Now the air is going to go towards the tank, so basically that way. I'm going to put that on there like so. Alright. And then what I'm going to do is I'm going to put one crescent right there, next one right here, and then I'm just going to turn the crescents against one another till I have a good, till I can't really easily turn it anymore. Yep. And the torque specifications we're going to use here today are it's a German torque. All right. I don't know. You ever heard of German torque? Who knows what it is? If you have, go ahead and make a comment about what is German torque. I could tell you, but I'm curious if anybody's actually watching this. So, if you know what German torque is, make a comment. And look at that. How about that? Okay? So, I might go ahead and make it one more on this side. I don't know. Oh, that's on there. Okay, so now what we've done is instead of this guy, we've gone ahead and we've put in this other little guy here. All right, we did some tool marks on there, but overall, I think this is gonna work very, very well. So we'll fish it back in here and do it in the order of which we took everything off, which the first is going to be this little pipe here. And so we'll get everything tightened down. Alright, so that's finger tight. Alright, now we'll move that guy to the side and get that lined up. Okay, that's that guy right there is sorry for the whoops. Oh no, that's what I wanted to do. This guy right here. Right, this little fitting right there. Okay. Let's try to do something different. Okay, tightened up. Okay, now, so that is finger tight. We'll come over here to the other side. And we'll go ahead and we'll 9/16. Try not to strip it. Whenever you're starting these things, you want to make sure that everything is going smooth, even if you use a tool to start it. So want to make sure that you don't have any extra resistance. My techs say that stripped screws are nature's Loctite. I think that's pretty funny. I would have to kind of agree. Alright, so now, still got the wrong size somehow. There we go, 7/16. Now, alright, so this is the last one, so I'm going to go ahead and smoke him down. Put some German torque on there. Don't know where I got that one from. I think I got it from, maybe from the flight line when I used to work on airplanes. Okay, nice and tight there. And then okay, nice and tight there. Okay, and then get this guy, 7/16. We'll tighten him down. All right, now, final. This is the final. All right, that's good. Everything is. Oh, that guy's good. Nice. Always double check your connections. Alright. Okay, tight. And tight. Alright. So now earlier I don't know how that happened, but kind of a pain. Alright, so now we're gonna reset our little guy. Oh, can't forget this. Now, where did that guy go? I think did I set it somewhere? Sure I didn't. Pretty awesome. There it is, right there. Alright, so that guy's going to go through there, And I'm going to just carefully use my 6-in-1. I guess I can't really break what's there. There we go. All right. So 6-in-1 for tightening down clamps. It's pretty awesome. Probably one of my favorite discoveries ever about this. All right. Ugh, nice and tight there. Yep. 5/16. 5/16 nut driver right there. All right. Now, let's go ahead and see if this thing behaves any different now. That's normal for it to lose about 5 pounds. So I would say that's acceptable compared to what it was doing earlier, where it was dropping all the way back down to 80 and resetting. And earlier in the day, I had not actually seen it work correctly. So we're going to make sure that as the purge cycle completes, that this stays right there around where it should. All right, which is around 95 or so. All right. Now we'll let this pressure go out to the office and then let it hit a cycle again. Okay, which is already out there, I guess. All right, let's make sure that, so that's where it's at when it stopped. Let's go ahead and bleed a little bit and then let it hit to 80, make sure it turns on. Alright, still holding firm. So that is what the repair looks like. That's how you can tell if you've had a new check valve. One thing I didn't talk about is where to get the part. Now, there's definitely, you can get it at one of two places. You can get it at a reseller who sells RPI parts. I can go ahead and list the part number right there for RPI. The other place you can get it, believe it or not, is Grainger. Now this is a check valve rated for air pressure, and the check valve is actually, believe it or not, this is the bag it came in, and this is what it is from Grainger. It's a 4DHU8. You can save a few dollars by getting that one. It's definitely been more than good for this application. It is a 1/4 inch check valve. So either way, this is now a repaired unit. We're sitting right at about 95 psi, like we should be. And again, what was really strange is that the issue we were seeing was actually intermittent in nature. So this is a good example of a problem that could befall other compressors like this. If you have a compressor that says Airstar like that, looks like that, it's maybe one of these styles that has this silver tank on it, this is something you want to be paying attention to. Alright, while we're on the topic of Airstar compressors, one of the things that you'll probably have if you have an older compressor like this is you'll have a manual that came with the unit. Now this manual can also be found online, and in here on page 8 in this manual there's actually what's called a post-installation check. And the post-installation check, what it goes over is the pump-up time and how long it should take to get from 0 to 100 psi. So we have an Airstar 50, so we're looking for a pump-up time from 0 to 100, in other words the time it turns off, initially of about 135 seconds, and then the recovery time is going to be from 80 to 100 psi. So the way a compressor works is in the beginning it starts at nothing and goes to 100, and then over the course of the day it will go to 80. It'll drift down to 80 and then pump back up to 100. Now this is a great way for you to tell how healthy your compressor is. If it exceeds these numbers, then that could be indicating that your compressor is in need of replacement. So before I finish with this compressor, I'm going to go ahead and run it, just making sure that it's within the cycle times of 135 seconds for 0 to 100 psi, and 43 seconds for 80 to 100. So let's go ahead and stop that, set it. Alright, I'm going to turn this on and hit start at pretty close to the same time. Alright, and oh, it's important that when you do this check that your office is valved off. Okay, so we'll go ahead and turn it on and turn that on. Right, 3, 2, 1. So we're about 15 seconds shy of the 215, which means that is good. Now we're going to go ahead and reset this. So that's 159. And usually what I'll do is take a screenshot of that. Now we'll reset it, and then I'm going to just go ahead and purge it so that it gets down to 80. And then once it gets down to 80, I'll go ahead and hit start. Alright, so 32 is well under 43. So again, we'll capture this for my records, and that is that. All right, there we go. This is you just witnessed a successful repair of a Airstar 50 that was running too much. I would highly recommend making sure that you understand your compressor and what it's doing. If you ever hear your compressor running more than you think it should, or more than it normally does, you want to stop and pay attention and try and understand why that happens. Air compressors are the lungs of a dental practice, and as soon as you allow your compressor to fall into a condition where imminent failure will occur, you run the risk of really losing out on profitable patient care time, as well as the inconvenience of having staff members in a dental office not able to practice dentistry because their air tools won't operate. Again, this is Jason from the Dental Equipment Repair Channel. Thank you so much for tuning in, and I hope you have a great evening.